Welcome to Curie Electronics. So in Quick Bite series, we are going to learn about ammeter and voltmeter and some questions on the same topic. First question. Permanent magnet moving coil instrument can be used in, that is PMMC, permanent magnet moving coil. And what is a PMMC instrument or permanent magnet moving coil instrument? It has got a this instrument has got a moving coil which is placed inside a fixed magnetic field, and this is used only for DC, that is DC current or DC voltage. So a permanent magnet moving coil instrument can be used only in DC work only. Option C is the right answer. So PMMC instrument can be used only for DC application. Next question. When high resistance is connected in series with a galvanometer, it becomes. So what do you see here? The photo or picture. This is the galvanometer. See what is the peculiarity of this meter? See, here is the zero. Zero is here at the center. And the deflector, this is the deflector, that pointer. This pointer can move towards left or right. And this galvanometer usually represented by like this, G. And this is used to measure in a very low level current, that is microamps, or else we can say this galvanometer is used to detect current and measure small amount of current. So what is the question? When high resistance is connected in series with a galvanometer. Okay, now if we connect, we have a galvanometer. If we connect high resistance in series with the galvanometer, that is RS. Now this is actually what? If we connect like this, it is a voltmeter. Again, one more condition we'll see, that is we have a galvanometer. We are connecting a small value shunt resistance. Shunt means in parallel. Then this will act as this RS, such we can call. Usually shunt resistance is very small value. So this is known as the ammeter. So if we connect a high resistance in series with a galvanometer, it is the voltmeter, and low resistance parallelly, then it is what? Not able to select, let me see. Then it is option A is the right answer. I'll write it here. Option A is the right answer. Now that is the voltmeter. Let's move to the next question. Okay, before going to the next question, I like to give you some more basics. Now we have seen the ammeter, galvanometer, ammeter is there. This is our ammeter. That is, to a galvanometer we have connected a shunt resistance in parallel, ammeter. See, this ammeter is used to measure the current. So we have a circuit like this. We have a DC circuit like this. Now if you want to know what is the current flowing through this circuit, we have to connect the ammeter. Is a voltage source. Let it be R1, R2. We want to know what is the current flowing through this circuit. Then we have to connect this ammeter in series with the circuit. That is what we will do. In series with the circuit we have to do. So we have to break open the circuit. Then we will insert the ammeter here. Now what you have done? We have connected the ammeter in series to measure the current. Ammeter always connected in series. Connected in series. So what about, okay, ammeter always connected in series. When you connect a ammeter in series with the circuit, the ammeter should have minimum resistance. That is, we can say ideally resistance of ammeter should be 0. Should be 0. So that it doesn't affect the current flowing through the circuit. Now what about a voltmeter? See, voltmeter means we can draw it as voltmeter. Now how do we connect a voltmeter? See, voltmeter is the similar circuit. If you want to measure the voltage across the R2, let voltage across R2 be V2. If you want to measure this voltage, we will connect this voltmeter parallel. Now this voltmeter show the voltage across R2. Now, so voltmeter should not draw any current from the circuit. It should show minimal current. Okay, very less current only should draw. So for that, voltmeter should have very high resistance. So similar, we can say ideally voltmeter should have what? Let me write it proper. Ideally voltmeter should have infinite resistance. That is infinite resistance. That symbol is infinite. Okay, infinite resistance. That means very high resistance. That is for the ideal case. So for a practical case, what we have? We'll have voltmeter resistance in terms of mega ohms. And what about ammeter? Practical ammeters will have micro ohm or milli ohm resistance. So this much we should know. Next, let's go to the next question. Which of the following is used to measure the current in a circuit element? So to measure current, what we use? We use ammeter. And how do we connect? We connect it in series. We connect it in series. Ammeter we will connect it in series. Oh, I'm not able to select the option. I don't know why. So let me write it. We will connect it in series. Okay. Ammeter in series to measure the current. Ammeter in series. So next question. This question you have to just remember, because we are not going to learn about this. A VTVM, vacuum tube voltmeter. Vacuum tube voltmeter. Voltmeter is never used to measure current. It is never used to measure current. Current is the answer because this has got very high input resistance. So it is never used to measure current. The option C is the right answer. That is current. A certain meter has a sensitivity of 55 followed by 4 zeros ohm per volt. The current required to, or 50,000 ohm per volt. The current required to deflect the meter movement to full scale will be. The current required to deflect the meter movement to full scale. This question is based on the sensitivity of the meter. Voltmeter. Sensitivity. Sensitivity to equals S equals 1 upon full scale deflection current. This I suffix FD means full scale deflection current. Full scale deflection current. Okay. Now let us put what is the question. We have to find what is sensitivity has given us. One more thing you have to see here. What is the unit of sensitivity? That is ohm per volt is the unit of sensitivity. Unit of sensitivity. Now AC has given what 50,000 equals to 1 upon full scale deflection current. Sorry, full scale deflection current. I supposed to write IFD. FSD, full scale deflection current. That is, now what will happen? Full scale IFSD, full scale deflection current is going to be 1 upon 50,000. So 50,000. What we get? This I will write it as 1 upon 5 multiplied by 1 upon 10 to the power 4. So 1 divided by 5, that is how much I will write here. Where I'll write it here, where I'll write here. 1 divided by 5. Here put a point 2 times. So that is 0.2 multiplied by 10 to the power minus 4. So we know 10 to the power minus 6 equal to microamps. So what we will do? 0.2 we will multiply and divide by 100. So 100 divided by 100 into 10 to the power minus 4, which equals 2 multiplied by 100 is what? 20. 1 upon 100 is equal to what? 10 to the power minus 2. When 10 to the power minus 2 comes up, what it is? 10 to the power minus 6 amps. So we can say it is 20 microamps is the answer. So right answer is 20 microamps. So what is the answer? Final answer 20 microamps. 20 microamps is the right answer. Next question. Here I will tell you one more concept. I think I have to quickly make it. Okay. See, you have a ammeter. We have a ammeter. Ammeter will have a resistance also. See, the arrangement is like this. We have a ammeter. Ammeter range is only 50 milliamps. But if we want to increase the range of the ammeter, what we will do? We will connect a resistance. That is the shunt resistance. The shunt resistor. So we have a ammeter and we want to measure a current of higher value, then we will connect a shunt resistance to make the ammeter for for measuring higher current. And now, so this ammeter, voltmeter all will have resistance. So now this ammeter I will represent by its resistance, that is Rm. Rm is the meter resistance. And to increase the current, we will connect a shunt resistance, RSH. Now, this I is the current, maximum current, this ammeter, that is the with shunt resistance, what is the maximum current this ammeter can measure, that is I. And the current flowing through the meter resistance is Im. And current flowing through the shunt resistance is ISH. Okay, I am not writing in word. Now, you should know, this much you should know. Now, let this terminal be A and the other terminal be B. Now, if you see, voltage drop across Rm as well as RSH is same because it's a parallel circuit. So we can write from here what we get. Here we get Rm multiplied by Im equals RSH multiplied by ISH. Right. This equation you should remember, and systematically you have to remember it, how it has come. Now let's go to the question. A precision current shunt is measuring 100 millivolt across it. Okay, across the shunt, that is, we have the equation Rm Im equals RSH ISH, and across the shunt resistance it is measuring 100 millivolt. That is, here we can write 100 millivolt. And this indicates current of 25 amps. What is the actual resistance of this shunt? This is the question is very simple. We have to take the right part only. That is RSH into ISH equals 100 millivolt. What we have to find? RSH, because ISH also he has given 100 millivolt upon RSH. ISH, what is the value of ISH? What is ISH? It is 100 millivolt upon 25 amps, which equals, millivolt means 10 to the power minus 3. Let it be there. 100 upon 25 equal to 4. So 4 multiplied by 10 to the power minus 3 ohm. 4 milliohms. So if you want to convert, what you will do? You have to divide 4 upon 1000. What do you get? 0.004 ohm. So 0.004 ohm is the right answer. 0.004 ohms is the right answer. Right. So next, let's see the next question. The unit for sensitivity of voltmeter is, already we have seen. What is the answer? Q ohm per volt. Ohm per volt is the answer. So we have completed this quick byte. It took more time. Actually, I wanted to give you a little more information in this video. Actually, we are not completed. Let me try one more video on this ammeter and voltmeter. Little bit error related questions. So if you like the video, please share with your friends and don't forget to hit the like button. And thanks for watching.